All right, so today we're going to continue with adding and subtracting rational expressions. And, yesterday we worked on finding a common denominator. That common denominator is the least common multiple of the denominators, okay? So again, adding and subtracting rational expressions, is definitely a lot more difficult than multiplying because of the whole common denominator thing, all right? So you always got to keep in mind you got to have a common denominator. So just to start off easy today, number one here, I have 3x squared divided by 4 plus 5x squared divided by 4. So they already have a common denominator. Both denominators are 4. So I can just go right across the numerator, and as long as I have like terms, I can add them up. So I have 3x squared plus 5x squared is 8x squared. Yeah, my denominator stays the same. My denominator is 4. When we get done, if you can simplify, definitely simplify. 8 divided by 4 is 2. So I can just leave my final answer as 2x squared. All right, again, just continuing with the theme of having a common denominator already. Let's say we have 4x squared divided by 5 minus 3x divided by 5. So in one like this, we do have a common denominator. My denominators are both 5. The only issue here is we have a 4x squared minus 3x. They are not like terms. So my final answer, I can write as one fraction. Just not going to be able to combine everything here. But you're good to go as far as the denominators go. Both of them have a denominator of 5. All right. One more with another common denominator would be, let's go with like 4x to the third divided by 7 plus 5x to the third divided by 7. So again, they're both x to the thirds. 4 plus 5 is 9x to the third divided by 7. And I would just leave that improper fraction. Don't try and do anything. But again, all of these had common denominators right from the start. So I was making life pretty easy right there. Okay. Moving on then, though, let's say we end up with something like this. All right, we can't subtract these right now, okay? Right now I have a denominator of 6 in the first fraction. My second one, I have a denominator of 8. So our first job then is to get ourselves a common denominator. So 6 and 8, LCM, least common multiple of 6 and 8 is 24. Okay, obviously they have a lot more common multiples, but 24 is going to be your least common multiple. You always want to go with the least one, just so it's better to deal with smaller numbers than larger ones. So I got to turn this into 24ths. So that means I got to multiply 6 by 4. So I'm going to multiply my first fraction by 4 over 4. Sorry about that. Again, to make that 24. Minus, I got to multiply my second fraction by 3 over 3 times the 4x. So this is going to give me 4 times 3 is 12x divided by 24 minus 3 times 4 is 12. 3 times 8 is 24. This will work out pretty nice here. So I end up with 12x minus 12x is 0 divided by 24. My final answer is just 0. All right. So again, you need to get that common denominator. All right, so next up then, x squared minus 2 divided by 12 plus x divided by 4. So to combine these, you get denominator of 12, denominator of 4, LCM of 12 and 4 is 12, okay? 12 is a multiple of 12, so don't do any more than you have to. Like, don't bump this up to like 24 and then you're multiplying this by 2, you're multiplying this by 6. So first fraction can stay the same, x squared minus 2 divided by 12, plus, to turn that into a 12, we got to multiply this fraction by 3 over 3. So I'm going to end up with x squared minus 2 divided by 12 plus 3x divided by 12. So now we're looking good. We got denominators of 12. We can add all this up. There's no like terms in the numerator, but that's fine. We can write as x squared plus 3x minus 2 divided by 12. Okay. So again, it's just trying to figure out those common denominators. All right. Okay, so something a little different here. We're throwing in some x's in the denominator. So this denominator I have 4x, this denominator I have 8. You always want to be thinking, like, how can we make these denominators the same? So, you're trying to assess, like, what is, each of them missing? Okay, so starting to think about it, we need to turn this 4 into an 8. Okay, 8 is a multiple of 4. This denominator is missing an x. So my LCM of 4x and 8 is 8x. So you want to be thinking, we got to turn each denominator into 8x. So what am I missing here to turn that into an 8x? Is I just got to multiply by 2. Multiply this by 2, I get 8x. So my first fraction is getting multiplied by 2 over 2, sorry. My second fraction, I got to turn this into 8x. So that's just missing an x. So I got to multiply by x divided by x. 2x minus 3. So, little distributive property here. We're going to get 6x minus 8 divided by 8x minus, we're actually distributing an x here, so we get 2x squared minus 3x divided by 8x. So we're good to go now. We have denominators of 8x and 8x. All right, the only thing you gotta be careful of here, if you want to combine everything, 6x minus 8, is that we're subtracting both those, so it'll be minus 2x squared and a plus 3x, all divided by 8x. So yeah, we gotta do a little cleanup here, for a final answer. So we'll have negative 2x squared. You do have a 6x plus 3x, we can write that as 9x. And then minus 8 on the end, all divided by 8x. And that would be your final answer then. All right. Where's that here? Okay, let's do one more like that. All right, so next up we got 2x minus 7 divided by 5x squared plus 3x plus 8 divided by 2x. All right, so first up, think of that LCM of 5x squared and 2x. So your LCM of 5 and 2 is 10. X squared and x, your LCM is x squared. So we got to make each denominator a 10x squared. Okay. So for my first denominator, I'm trying to turn 5x squared into 10x squared. So all I got to do is multiply by 2 over 2. That one's not too bad there. I gotta turn my 2x into a 10x squared. So I gotta do 5, I gotta multiply by 5, and I gotta multiply by an x. So multiplying by 5x divided by 5x. So up here, I'm going to come out with 4x minus 14 divided by 10x squared plus 15x squared plus 40x. And my denominator is 10x squared. All right, so to put it all together here, we're doing addition this time, so I don't have to go worry about any of that distributed stuff like last time. We'll have 15x squared. I have 4x and 40x, so it'll be 44x minus 14, and it's all divided by 10x squared. Okay, so again, you always want to be thinking, what are we missing? So trying to turn this into 10, I got to multiply by 2. I already got the x squared. Over here, I only have 1x, so I got to add another x in there, so that's why I'm multiplying by the 5x. All right, but getting those common denominators. So that's why adding and subtracting polynomials is so much more work than multiplying because of the whole common denominator thing. All right.